So uh, we can always write acid-base reaction and when in talking in terms of Bronsted-Lowry in terms of transfer of proton. So HNO3 gives this, and if we have water, it will accept it. And if you this will like electrons cancel out, you will get this equation HNO3 plus H2O gives NO3. So this generally we keep acids bases here and the conjugate base, and we call it conjugate acid here. Why? Because this will conjugate bases, it will accept a proton now and convert to this. If it loses a proton and converts to this, it can always accept a proton and convert to this. So then this is a base. Here it is an acid. Similarly, this is accepting this, it's a base acting here, but here it can again give it away. But if won't give it away depends on which is stronger. Is this stronger or is this weaker? Generally, whoever is the stronger acid will have a weaker conjugate base. So uh, in general, weak acid, like if it's weak, they will produce strong bases. And if it lies to the right, is lying to the right, that means you have got more of this. That means you have got a strong acid because it has dissociated and this is not able to accept it back and go backwards. But if it goes backwards, then this is a weak acid, stronger, and this is a stronger base. So then it shifts to the left. Generally, H2SO4 is very strong, so its base is weak. Conjugate base is weak. H2SO4 will generally appear on this side, not here. So it will never be. And like if HCl is strong, Cl minus is weak. HCl is here, Cl minus will come here, and the it will be to the right because this is a weak. The equilibrium will be to the right because it's a weak conjugate base, and the acid will be on this side. So this is how you see, and also it's all relative. Like if we have got HNO3 and H2SO4, out of these, who's more acidic? Now this is more stronger, so this will act as a base. It will accept the proton. It has added one proton, and this has given away. This is a very strong base. This is the weak acid, a weak conjugate base. So the equilibrium will be to the left, and this is then used a nitrating, like he's using the relative. For example, if two acids are right, the weaker acid will be forced to act as a base. Weaker acid will be forced to act as a base. For example, when concentrated a nitrating mixture contains a cation called NO2 plus. This you can you can break this up into water and this HNO2. Yeah. So this ion is involved in the nitration because this can be this is used. So this has this is strong weaker acid, so it acts as a base.